This is phase transition video number 2. By the end of this video, you'll be able to identify the state of matter of a substance using a phase diagram. In order to do this video, you should have your phase transitions video number 2 worksheet and a pencil. This is the typical outline of a phase diagram. Each substance will have its own temperatures and its own pressures depending on what the substance is, but they will all have the same basic outline. One thing you should note about a phase diagram is that the state of matter, if a substance is a solid, liquid, or gas, will depend upon temperature, but it's also going to depend upon pressure. Now this is unique because we're used to things determining what they are by the temperature. For example, at 32 degrees Fahrenheit, liquid water will freeze and become a solid water or ice, which of course makes snow emergency days and helps us to get out of school. But it's showing here that pressure also has an impact. The first thing you should be able to do is to show where the solid, liquid, and gas is on your phase diagram. So let's take a look at this. Down here, the temperature is going up. As the temperature goes up, you expect to have a gas, especially since down here you have a very low pressure. So in this region, you will have a gas. High temperatures, low pressures are ideal gases. Down here, the temperature is getting low. You expect to be freezing, especially with the pressure increasing. So this is going to be your solid. The phase in between gases and solids is a liquid. So if, for example, you're at this point, you could say that you are a gas. If you're at this point, you could say you're a liquid. If you're at this point, you could say you are solid. Another thing you should be able to say is what happens when you move from one point to the next. So if we were moving from here to here, and we were going from being a solid to being a liquid, then you should be able to tell me what phase transition occurs when we cross the barrier line. In this case, as my temperature went up and I went from here to here, from a solid to a liquid, this will be melting. If you went from here to here, from this point down to this point, your temperature is not changing, but your pressure decreased. You're going from a liquid to a gas state. This would be called vaporization. Now, as you can see from the diagram, there are multiple places that you can go between a solid and a liquid. So this would be one melting point. But this would also be a melting point, and this would be a melting point. And if we were going backwards, this would be a freezing point, and this would be a freezing point, and this would be a freezing point. So you can have more than one melting point or more than one freezing point. Now, the same thing can occur for vaporization. Vaporization can occur here, it can occur here, down here again. There's multiple places where vaporization or the boiling point occurs. Likewise, if you're going the other way, from gas to a liquid, it would be the condensation point. Now, this can become complicated because having more than one possible melting or freezing point, because it's a combination of pressure and temperature, can lead to some confusion when one person is talking to the next. So we usually talk in terms of the normal melting point, the normal freezing point, the normal boiling point, and so forth. So normal melting point will be the melting point at 1 atm. So let's say this diagram showed this point here to be 1 atmosphere, which is the typical standard pressure day. To find out the normal melting point, you would go across, find the point on the graph at which you go from a solid to a liquid at 1 atm, and then, reading the graph, drop it down to the temperature. So that when you get to the bottom, this will be your normal melting point, or it could also be considered your normal freezing point depending on the direction you're going in. Likewise, to find the normal boiling point, you keep moving along at 1 atm until you find the point that a liquid becomes a gas at 1 atm. Drop down your temperature and this will be your normal boiling point. So normal melting point is the temperature at which a solid becomes a liquid at 1 atm. Normal freezing point is the temperature at which liquid becomes a solid at 1 atm. Normal boiling point is the temperature that a liquid becomes a gas at 1 atm. But boiling point in general is any temperature where a liquid becomes a gas at the given pressure. Now we have talked about what happens when we're at specific points on the line. Are we going to be a solid, a liquid, or a gas? But what happens if we're right on the line, excuse me for that, liquid, or a gas? But what happens if we are directly on the line and we're not moving? So we're here, but we're not changing from one state of matter to the next. We are directly on the line and we're staying on the line. What happens there? Any point on the line is going to be an equilibrium between two states of matter. So this is an equilibrium point between solid and liquid. You have both solid and liquid present at the same time, going back and forth, melting and freezing, so that you overall see no net change. This, etc. are all equilibriums between liquid and gas, where you have liquid vaporizing becoming a gas, gas condensing becoming a liquid at the same rate. So you have an equilibrium. Here you have an equilibrium between solid and gas and so forth. Any place on the line is a point of equilibrium. You may have noticed that this line here, between solid and liquid, goes up to the edge of the graph and stops. Same thing down here. It goes all the way to the edge of the graph. And the reality is, if the graph continued, the line would continue as well. However, this line here stops. The reason why is this point here is called a critical point. It's critical because you can almost imagine a line coming above, straight above. And everything beyond this point will always be a gas. What happens is that a liquid cannot exist above this temperature. The temperature is so high that the intermolecular forces break, and that's the end of it. So this point right here is called a critical point. The critical point indicates the critical temperature and pressure of a substance. Now, we've alluded to what this critical temperature means. That temperature is the lowest temperature that a gas would exist, or anything above this temperature must be a liquid. So once when you go above this temperature, the liquid can no longer exist and you must have a gas. The pressure that corresponds to this temperature is called the critical pressure. The critical pressure is the lowest pressure that you can have a liquid at the critical temperature, because there's a lot of pressures up above that can still be a liquid. But that's the lowest pressure that at that temperature will be a liquid. The last point that is somewhat unique is right here. This is called a triple point. Now the reason why it's called a triple point is because it is the one temperature and pressure combination where all three states of matter, solid, liquid, and gas, are in equilibrium with each other. So the triple point is a pressure and temperature combination where gas, liquid, and solid are all in equilibrium with each other.